So now I have my setup here assembled. I have some modifications to the frame, but now it seems like I can move the wall stuff. So let's see. I put here a 3D printed tensile specimen and fixed it to the grips by 4 screws. There are no nuts on these screws, so the screws are just going through the hole, and nothing is holding them against the surface of the grip. But yeah, that's not important at this moment. What is important is this gear here. So I have added the worm gears, and now, as you can see, the worm gears are on a shaft fixed with 2 pillow bearings, and they are fixed to a slotted plate. Also, I have fixed the slotted plate to the frame, so there are no distortions and no motions, unnecessary motions. And then the worm wheels are on the 2 lead screws. The setup is very slow because the ratio of this gear setup is 1:20, so you have to do 20 revolutions with the worm gears to do 1 revolution with the worm wheel, so it's very slow. And I have my stepper here. This is with the 1:100 gear ratio, and now I have this helical gear, and at the end, I don't exactly remember, but I think it has either 40 or 60 teeth, and we have this small guy here, and maybe it has 20 teeth. So yeah, it's like 1:3 or 1:2 gear ratio. I don't remember. And yeah, so this wall setup is also fixed on a plate with holes, as you can see. It's not the perfect. I have some problems with fixing the stepper motor itself, because it tries to rotate and tries to move back and forth due to the forces between the 2 gears. So it's a bit difficult, but seems like this homemade setup, I try to go around, so this homemade setup holds it. So I screwed this profile against this 90-degree piece of metal. I don't know what's its name. And also I have this one piece of metal here and one piece of metal profile here, which are holding the motor back. So I tried to go and install the mount in between the motor and the gear, but yeah, the axis is just the shaft is not long enough, which comes out from the motor. So yeah, I have to leave it as it is. And yeah, still this is just a prototype, but now at least I have the full circle of the motion, or whatever we call it. So if I run the motor, it will move the grips, and this is what I'm going to introduce in a few seconds. But yeah, and now this is just a very simple circuit. So I have an Arduino which receives the command from the computer, and then I will use this small stepper motor controller in order to control the stepper motor. So it's a very simple setup, but what I want to show now, so I will give the command on my computer, you will hear a very high-pitched noise, and probably the sample will break in a few minutes. I strained a little bit. I mean, yeah, it's still not too rigid, but it's close to being rigid. But there is no pressure or there is no stress on the sample yet. But at least the setup is a bit more tight than it was initially. So let's go and try to run the motor. So now, as you can see, and I hope you can hear the record, it runs quite slowly. So you have one motion here and then 90 degrees turn, and then this rotation is transferred to these gears. If you follow the nuts down here, yeah, now it's not visible, but you can see that it is definitely moving, but it's not the best. Yeah, it's coming up, so you can see it. So it goes quite well. So then, yeah, I guess we just wait here and then see what will happen. I try to move closer a bit, maybe like this. Ah, I heard some cracking noise. But the motor still runs, which is a good news. So nothing is stuck and the gears move smoothly. I spent 2 days to find this setup which works. So I basically disassembled the whole stuff and assembled it again, and then I tried to figure it out how to arrange the gears. Should I put the worm gears above the worm wheels or below them, and what parts should I use, and so on and so on. But still, I see that the end of the sample is a bit like bending up, because I haven't fixed it, of course, but that won't cause any issues. Aha. So now the torque which is needed is quite high, so yeah, this just doesn't want to turn properly, but let me help. this terrible noise. So the sample is broken now, and it is broken but not at the ideal point. Okay, so I had some issue during the test, which was here at the gears. So due to the poor setup, which means that I was not able to fix this motor properly to withstand the forces which are created during the rotation. As I said in the beginning, that these two gears are pushing against each other. So that's what actually happened. So if you see that these two gears are not well aligned, but they should be aligned, but the motor got pushed back from the shaft because of the forces. So I have to fix this. I have to build a sort of mount or a nest or something for this motor, and it will be fine. But I think that's all for now. So at least I discovered some flaws again. So I see that the motor or the mounting of the motor is very critical. But on the other hand, we saw that this works. So we can break small plastic specimens, and we also saw that this kind of setup with the two worm gears and worm wheels are quite nice. And I think that this guy here with the helical gears works pretty well as well, but the problem is with this fixture. So I will do some measurements, and I will prepare a proper fixture for this stuff. So then I will be able to hold the motor properly, and I will be able to run a proper test, maybe with the more tough material which requires higher stress to break. So yeah, that's for now.